My name's Sam McKee, and I manage one of the mechanical design teams here at Domin. In applications like that, where dynamic performance is critical, manufacturers use aerodynamics to increase the cornering and braking forces that tyres can generate. We do this by using aerofoils, like you'd see on an aircraft to produce lift, but mounted upside down to produce an aerodynamic downforce, acting on those tyres. That increases the force they can generate at the contact patch without increasing the mass of the car. It's fantastic for cornering and braking performance, but the trade-off you pay is it produces drag. So that means the car will be less efficient in a straight line, in motorsport, slower down the straight, or in a road car, less efficient cruising on a motorway. So to get around that, you use an active system to allow you to stow those devices out of the airflow when you don't want them and deploy them when you do. If we consider a road car, which could be 1.5 tons, if we want to make a meaningful difference to its performance, we need to generate quite a large aerodynamic force. And that means we're going to need a correspondingly large force at our actuator. We also need to be able to move those surfaces quickly and precisely. If we think of driving a car like that on a racetrack, rapidly changing loads and conditions, the driver needs to know very intuitively that the car is going to behave in the same way every time. So we need fast and precise response. We also need to be aware that mass and package space are always at a premium in automotive and motorsport applications, so we need great power density. We need to be able to produce these forces in a small and compact and lightweight package. And for that, really, hydraulics is the only viable option, and we're seeing all of the leading applications tending in this direction. I think we're already seeing quite a significant trickle down from what was previously only top-end motorsport, exotic hypercar kind of applications, technology showcases almost, into far more mainstream vehicles. A lot of mass production sports cars are using hydraulic active aero already, and as we continue to miniaturize these systems and make them more efficient, that will continue to grow, and you'll be on high performance saloons and even hot hatches in the not too distant future. I think the other thing we'll get is greater integration with other systems on the car. The aerodynamic surfaces are not the only thing where you want this continuous optimization for the conditions. We could be tying this hydraulic power source not just to aero, but also to brake-by-wire, to steer-by-wire, to active suspension systems. Once you've got that power source on there and your hydraulic control, you can actually open up a load of other avenues to make sure the car is always optimized and never compromised.